Hey everyone, and welcome to another deep dive. Today we're going to try and get to the bottom of this whole large language model thing.
Right.
These LLMs like ChatGPT, BARD, all these things that seem to be everywhere these days.
Yeah, it's certainly been getting a lot of attention.
It really has, and to be honest, I'm a little curious about how it all actually works. So
Sure.
today we're going to try to break it down, cut through the hype a bit, and luckily we've got some sources that promise a very gentle intro to this whole world. So
Absolutely.
you don't have to be a coder or anything to follow along,
Oh,
which is
no.
good because I'm definitely not.
Yeah.
But to help us make sense of it all, we've got our expert here. So
Happy to be here.
excellent. Maybe let's start with just the term artificial intelligence. What does that even mean?
Yeah, it's one of those terms that gets thrown around a lot. There's no one definition everyone agrees on.
Right.
But basically, you could say if something made by us, humans, can do something that seems complicated, seems like it takes intelligence, we tend to call it AI.
Okay, so it's kind of a moving target in a way,
Yeah. Yeah, exactly.
depending on what we're currently impressed by, I guess.
Exactly.
So where does this whole machine learning thing fit in? That seems to be a big part of how these LLMs actually work.
Right. So machine learning, it's a way of achieving artificial intelligence. Instead of programming every single rule like you would with traditional software,
Yeah.
you feed a ton of data to algorithms that can actually find patterns in all that data and then learn from it. So they create this model of how things work.
So it's like instead of describing a cat to a computer, you just show it thousands of pictures of cats and it figures it out.
Exactly. That's
Ah.
a great way to put it. And with LLMs, it's the same idea, but with language. We're training these models on massive amounts of text.
That just seems so wild to me. Like, how do you even begin to teach a machine something as complex and nuanced as language?
Right. So it's important to remember it's not understanding in the way that we understand language.
Okay.
It's more about recognizing these patterns on a massive scale. And this is where neural networks come in.
Okay, I've heard that term, but I'll be honest, I don't really get what it means.
So imagine like a self-driving car.
Okay.
It doesn't have a human brain telling it, okay, now turn the wheel, now hit the brakes. It's got all these sensors, right? And the signals from those sensors, they flow through this complex network, kind of like circuits in a computer, but way more intricate.
So instead of thoughts, it's like electrical impulses making the decisions.
Exactly. Now, imagine you could tweak those circuits to control how the information flows.
Mm-hmm.
That's essentially how a neural network learns. It adjusts these internal connections based on the data it's getting.
So it makes tiny adjustments until it can recognize a stop sign or turn left when it's supposed to.
Exactly. And that process of adjusting those connections based on data, that's the learning part of machine learning.
Fascinating. So we've got these networks that are learning to process information, but how do we go from circuits and sensors to actual language?
That's the cool part. So instead of teaching a car to drive with language models, we're teaching a machine to navigate the world of words.
Okay, I'm listening.
So picture this, a typewriter.
All right.
But instead of keys for just letters, it's got a key for every single word in its vocabulary.
Wow, that's a lot of keys.
Right. And it basically calculates the probability of one word following another based on all the text it's been trained on.
So if I say once upon a May,
Yeah.
it's more likely to predict time than washing machine or something.
Exactly. It's all about these statistical likelihoods based on the patterns in the data.
That makes sense. But how does it even process that much information? We're talking about what, billions of words?
Billions, trillions, yeah. That's where it gets even more wild. They use this technique called encoding and decoding.
Okay, I got to be honest, those words sound kind of intimidating. What is encoding and decoding?
Okay, imagine you want to send a really, really long text message.
Okay.
But you've got a strict character limit, right? So you might try to compress it somehow, make it shorter.
Right, like zipping a file to make it fit on a flash drive.
Perfect analogy. That's basically what encoding does. It takes the meaning of words and compresses them into these smaller chunks of data.
Okay.
And then, just like you can unzip that file to get the original message back, the model uses decoding to translate those compressed chunks back into actual words.
That's really incredible when you think about it. So it's like this whole other language, but for machines.
Exactly.
But how do they even learn which words go together or make sense in the first place?
That is the million-dollar question. That's where self-supervision comes in. And this is one of the things that's kind of blown my mind about this whole field.
Self-supervision, so they're teaching themselves.
Kind of, yeah. It's like giving someone a giant puzzle book, but no picture on the box, and just letting them have at it.
Okay, that's a terrifying puzzle, but I kind of see what you mean. So how does it actually work?
So let's say you take a sentence and you blank out one of the words.
Okay.
Like, the blank barked at the mailman. The model's job is to guess what that missing word is based on the words around it.
So in this case, it would probably predict, like, dog.
Exactly. And it learns by checking its answer against the actual word. If it's wrong, it adjusts itself a tiny bit, those connections we talked about earlier, and then it tries again, over and over again.
So it's constantly practicing, making mistakes, improving, all without someone, like, explicitly telling it what to do.
Exactly. And because it can do this with just massive amounts of text, it can learn these really nuanced patterns and relationships between words that we just couldn't program by hand.
This is amazing. But I have to ask, if it's just about predicting the next word, how is it writing poems, answering complex questions? That seems like a bit more than just word association. Like, what's the secret sauce?
Right, that's where things get really interesting, and that's where we get to these things called transformers, which is the technology behind models like ChatGPT.
Okay, Transformers.
Yeah.
Like Optimus Prime, robots in disguise.
Yeah. Not quite. No robots in disguise, although it can feel like that sometimes. But transformers, they're a big deal in the world of LLMs. They brought us this thing called self-attention.
Self-attention.
Yeah, and this is where it takes word prediction to a whole new level.
All right, break it down for me.
So think about how we understand language as humans.
Okay.
We don't just take each word on its own. We understand the relationships between them, right? Self-attention basically lets LLMs do the same thing.
Okay, I think I need an example.
Wait.
Like, for instance...
Okay, imagine the sentence. The alien landed on Earth because it needed to hide on a planet.
Yeah.
Self-attention lets the model connect alien, landed, and Earth and understand that it refers back to the alien, not to the planet.
So it's like the model is learning grammar, context clues like we did back in elementary school.
Yes, exactly.
Yeah.
But on a much, much grander scale, right? It's analyzing these whole sequences of words, figuring out which parts are related and how they all contribute to the meaning.
This is blowing my mind, I gotta be honest. This is incredible. Okay, so we've covered, what, AI basics, neural networks, these transformer things. But I think we gotta address the, like, elephant in the room, or maybe the potentially sentient AI in the computer. Like, why do these LLMs seem so intelligent, and are they actually thinking?
That's the big question, right?
Yeah.
And it's a complicated one. I mean, on the one hand, these LLMs can do some really incredible stuff. Creative writing, answering complex questions, even generating computer code, all the stuff that seems like it would require, real intelligence.
Yeah. I've seen some of the stuff these models can do, and it's honestly a little freaky how good it is. But I still have this, like, nagging feeling that it's all just smoke and mirrors, Like, are they really thinking, or are they just really good at pretending to?
It's a valid question, and the short answer is no, they're not sentient. They don't have thoughts or feelings or desires the way that we do.
So no robot uprising anytime soon.
Not that we know of, at least. But they can create this really powerful illusion of intelligence. And that's down to a couple of things. First, the sheer volume of data they're trained on. I mean, we're talking a huge chunk of the internet.
So they've basically seen it all, read it all, processed it all.
Pretty much. And the second thing is the power of this transformer architecture. They can mix and match all those learned patterns in these crazy complex ways. Like, imagine giving a master chef an unlimited pantry of ingredients and the ability to combine them in ways we couldn't even dream of.
Okay, so they're not actually thinking, but they're incredibly good at, like, simulating the results of thinking.
Exactly. And that brings us to this really important point about LLMs and how they work. Because they're trained on such a massive, diverse data set, their output is kind of like an average of everything out there.
Average? So
Yeah.
you're saying ChatGPT is the, like, James Bond of mediocrity?
Well, not quite. But it's important to remember, at its core, it's a pattern matching machine. It's really good at producing text that reflects the most common pattern, the most common information in its training data.
So we shouldn't be too quick to, like, assign intelligence or creativity to the model itself.
Right. It's a tool, an incredibly powerful tool, but it's still a tool. And like any tool, it's important to understand both its capabilities and its limitations and use it responsibly.
That's a lot to think about. But before we go there, there's one more tech term I keep hearing that I need you to explain. What in the world is reinforcement learning from human feedback? RLHF, everyone keeps saying.
Oh, yes, RLHF. The secret sauce that makes models like ChatGPT so damn charming.
Okay, so what is it? Explain it to me like I'm 5, but also like I have a PhD in curiosity.
All right, so imagine you're training a dog.
Okay, I can do that.
You give it treats when it does something good, right? Positive reinforcement.
Right, that's how I finally got my cat to stop sleeping on my keyboard most of the time.
Exactly. Well, RLHF is kind of like that. It's about refining the model's responses by giving it feedback, like a thumbs up or a thumbs down.
So it's learning to be a people pleaser, basically.
In a way, yes, but it's also learning to align its responses with our preferences, our values.
Okay, so how does that work practically?
Remember we talked about instruction tuning, like teaching the model to follow instructions, like write me a haiku about a squirrel.
Because who doesn't love a good squirrel haiku, right?
Exactly. RLHF builds on that. Let's say the model writes a haiku. With RLHF, human reviewers would look at a bunch of different versions of that haiku and say which ones are good, which are bad, that kind of thing.
So it's like A/B testing for AI poetry.
Right. And all that feedback gets fed back into the model so it can learn what kind of responses get the thumbs up from us humans.
So it's always learning, always refining.
Right. But here's the thing. Even with RLHF, it's still fundamentally a pattern matching machine. It doesn't actually understand why one haiku is better than another.
So even though it feels like I'm having a conversation with a sentient being, it's really just a very, very sophisticated echo of everything it's ever read.
That's a great way to put it, yeah.
Wow, okay. This is already a lot to unpack. We've covered so much ground just on how these things work, but we haven't even gotten into the implications of it all. And that's exactly what we're going to dig into next. So don't go anywhere. We'll be right back after this. Okay, so we've established that LLMs are really good at this pattern matching thing
Yeah.
to the point where it's almost like unsettling how convincing they can be,
Right.
but they're still just reflecting what they've learned. They're not actually getting it in like a human sense.
Exactly. Like that mirror analogy we were talking about earlier.
Right, exactly. So we've talked about how they work, but what does it actually mean? Like, what does it mean for us to have these incredibly sophisticated language tools just like out in the world?
Yeah, I mean, that's the question, isn't it? And I think a lot of people are still trying to figure that out. Because, on the one hand, you can imagine all this amazing stuff, right? Like, imagine if you could have something that summarizes really complicated information instantly, translates languages perfectly, helps you write.
That would be amazing.
Right, so the potential is huge.
It is really exciting, but I also, I can't help but imagine some downsides too, you know? Like, what are people worried about with this technology?
Yeah, and there are some valid concerns for sure. I think one of the biggest ones is just misuse, right? Because if they're so good at generating human quality text, you could use them to make really convincing fake news,
Oh, yeah.
spread misinformation, even impersonate real people online. That kind of thing is a worry.
Right. So it's not so much the technology itself, but how it's used.
Exactly.
Which, I mean, I guess that's true of a lot of technology.
It's like any tool, right?
Yep.
A hammer can build a house, or it can,
Cause some damage.
Exactly.
So how do we make sure these tools are used for good then?
Yeah, that's the million-dollar question. And I don't think there's any easy answer. It's going to take a lot of different approaches.
Well-
Like, researchers are working on ways to detect and mitigate bias in these models.
That's good.
Trying to make them more transparent so we can understand how they're making decisions.
So kind of like lifting the hood a little bit.
Exactly. And then there's the policy side of things, right? Like, we need to figure out what kind of guidelines or regulations make sense, especially in areas like, journalism, education, things like that.
It seems like a lot of different people need to be involved to make this work well.
Absolutely. It's a team effort for sure. But I think ultimately it comes down to education. The more people who understand how these LLMs work, what they're good at, what their limitations are, the better equipped we'll be to actually use them well.
So knowledge is power, even when it comes to AI.
I think so, yeah.
I like it. Okay, so practical side of things for a second. What are some of the applications people are most excited about right now? Like, where are we actually seeing LLMs make a difference?
Oh, gosh, there are so many. I mean, in healthcare, people are using them to analyze medical records,
Yeah.
help with diagnoses.
Okay.
In customer service, you've got these chatbots that are getting way more sophisticated,
Right.
more helpful. Education, there's this potential to personalize learning.
Yeah, make it more tailored to each student.
Exactly. And I mean, those are just a few examples. As these things get more advanced, I think we're going to see applications we haven't even thought of yet.
It's kind of both really exciting and also a little, I don't know, intimidating. Like it's hard to even imagine what that future looks like.
It is. It's like we're at this really interesting point in time, right, where things could go in so many different directions.
Yeah. Okay, so we've talked about how they work. We've talked about the good, the bad, the potential. But I want to go a little deeper here, if you're up for it.
Sure.
So we've said that these models don't actually think like humans do, but they are able to mimic human language in a way that's honestly pretty uncanny.
Mm.
Does that make you, like, question our own understanding of intelligence at all?
It's a good question. It's a question that honestly philosophers have been debating for centuries, right? Like,
Right.
as we build these machines that can do things that we used to think were uniquely human, it makes you wonder, what does it actually mean to be intelligent? What's the difference between just recognizing patterns really well and actually understanding something?
Right, yeah. It's almost like we're holding a mirror up to our own brains, trying to figure out how they work by building these artificial ones.
Exactly. I think that's a great way to put it. And it's possible that in trying to create AI, we're going to learn just as much about ourselves.
This is a really trippy thought.
Yeah.
But it also makes me wonder, like, if a machine can write a poem that makes me cry or compose a piece of music that gives me goosebumps, does it really matter if it doesn't actually feel those things the way I do?
Yeah, that's a big one, right? That gets into this whole debate about consciousness,
Right.
which is a whole other can of worms.
Oh, for sure.
But it's a question we may not have an answer to for a long time, maybe ever. But it's something to think about as we develop these AI systems.
Yeah. It really makes you think about, like, what does it mean to experience something, to feel something?
Right. And can a machine ever truly replicate that?
Yeah, exactly. Okay, we've covered a lot of ground here.
We have.
And I think it's time to shift gears a little bit and talk about what all of this means going forward.
Oh.
So don't go anywhere. We'll be right back after this to unpack the implications of all this. All right, we're back. We are in the home stretch of our deep dive on large language models. And I got to say, this has been a lot to process,
It really has.
but the best way possible, you know?
Absolutely.
So we talked about how they work. We talked about the good, the bad, the potential.
Yeah.
But, like, what's the takeaway here? Where do we even go from here?
Yeah, those are the big questions, right? And like we said before, there aren't any easy answers.
Right.
But I think one way to think about it is at their core, these LLMs are tools.
Tools. Okay. So, like a hammer, a screwdriver, but for language.
Kind of, yeah. And just like a hammer, you can use it to build something amazing, or you can use it to cause some damage, right? It all comes down to how we choose to use them.
So it's about intention. It's about responsibility.
Exactly. And that's why I think these conversations are so important,
Yeah.
because we have to engage with the ethical side of this technology.
Right. It's not just about, like, ooh, shiny AI. This is cool.
Exactly. We can't ignore the potential consequences.
For sure. So how do we do that? How do we make sure they're used responsibly?
Well, I think one really important thing to remember is that these models, they're products of their training data.
Right. Which is basically the internet.
Right. So all the biases, the assumptions, the limitations of that data, it's all baked in.
So if we're not careful, we could end up just amplifying all those problems without even realizing it.
Exactly. We have to approach LLMs with a critical eye, be aware of their blind spots, and always, always consider the source.
Right. Like with anything on the internet, don't just believe everything you read.
Exactly. And that kind of critical thinking is going to be more and more important as these models become more sophisticated.
Yeah, it's like we need a whole new set of digital literacy skills to navigate this stuff.
I think that's a great way to put it. It's not just about, like, using the technology, it's about understanding it.
Right, exactly. So as we wrap up this deep dive, I want to leave our listeners with something to chew on, a bit of a thought experiment. Maybe
Okay.
we've talked about LLMs as tools, as mirrors, even as potential threats.
Right.
But what if we thought about them as partners? Partners in this future where humans and AI are working together to solve problems, to be more creative, to build a better world.
I love that. I think that's a really powerful way to look at it, because these LLMs, they can do some incredible things, but they don't have the same values, the same hopes, the same capacity for empathy that we do.
That's a really good point. It's not about replacing human intelligence. It's about, like, expanding it.
Exactly. It's about what we can accomplish together if we use this technology thoughtfully and ethically.
I love that. Well said. And on that note, I want to thank you all for joining us on this journey into the world of LLMs.
It's been a pleasure.
That's been a wild ride, but hopefully an enlightening one. And remember, this is just the beginning of the conversation. AI is constantly evolving, so stay curious, stay informed, and most importantly, stay engaged. Thanks for listening, everyone.